means the combination of two or more peptide chains which already obtain tertiary structure. Combination of two or more polypeptide which already obtain adopted tertiary structure. So each polypeptide, in this case we call it a subunit. And the subunit can link together by hydrogen bond or by hydrophobic interaction. For example, hemoglobin is a protein which consists of 4 globin chains, in which we have 2 alpha globin and 2 beta globin. So this is a quaternary structure of hemoglobin. So at first, globin, when globin is synthesized, it has a primary structure, which is the chain of amino acid or polypeptide. Then the backbone of this polypeptide form hydrogen bond together to form either alpha helix or beta sheet. In this case, it's adopted secondary structure. And then due to the property of amino acid, protein form tertiary structure by the introduction of side chains in amino acids. So this is the structure of one globin subunit. 4 globin subunits combine together to form a quaternary structure. This is the structure of hemoglobin. And of course, inside this there is a heme ring with ion to carry oxygen. So we will come back to hemoglobin later. Yes.
Vậy là từ cái primary tới cái tertiary đó là chỉ có một cái
chuỗi thôi.
Chuỗi, nhưng mà cái quaternary này á là nó có 2 hoặc là nhiều chuỗi.
Nhiều chuỗi kết hợp lại với nhau. Thì cấu trúc bậc 4 là khi mà có nhiều chuỗi kết hợp lại với nhau. Còn cấu trúc bậc 1, bậc 2, bậc 3 là của một chuỗi polypeptide. Đôi khi có những protein nó chỉ cần một chuỗi polypeptide là nó đủ hoạt động rồi. Nhưng có những protein nó cần tới 3, 4, chỉ là nhiều chuỗi polypeptide ghép vô thì nó mới hoạt động được. Okay, so protein characteristics. A protein can have both acidic and basic properties. Why? Because amino acid we have both acidic amino acid and basic amino acid. So a protein, the portion, the part of protein which contain acidic amino acid may have acidic property. The portion of protein, a part of protein which contain more basic amino acid may have basic property. So protein can be protein can have both acid and acidic and basic properties. And protein can be aggregated or denatured. Aggregation and denaturation. Aggregation. What is aggregation? As I said before, in the very first slide of this lecture, I shown you that water usually linked to macromolecules, including protein. For example, in this structure, the blue and cyan color stands for molecules of protein, and red and white color stands for water molecule. So here, water molecule form hydrogen hydrogen bond with amino acid, which is hydrophilic amino acid on the surface of protein. So those water molecules help stabilize the structure of protein. So if water fill the distance between the two protein moieties, the two parts of protein, and keep its structure stable. So in case of if the water molecule is evaporated, is removed, this structure cannot be kept. The two moieties of protein can bind together, may bind together. So this protein lose the natural structure or functional structure. In that case, it will aggregate because the two parts of protein, bind to each other.
So does it cause blood clots?
Cấp tủa.
Cấp tủa máu.
Hả? Không phải, cái này là cấp tủa của protein thôi. Tủa của protein. So you imagine water molecule fills between the two parts of protein. Water molecule fills between the two parts of protein. If those water molecules are removed by evaporation or by strong basic solution, the two parts of protein can bind together, and this protein lose native function. We call it aggregate. Aggregate. So aggregate happen when the surrounding water molecules of protein are removed by chemical factors such as pH, salt, temperature. So the water can be evaporated and protein lose the water, surrounding water. It becomes aggregate. This is aggregate. This is the nature of protein, nature structure of protein. Usually it has water molecule around it. For some reason, water molecule around protein is removed. Protein will aggregate. It means protein bind together. If there is water bind to protein, bind to the surface of protein. So these two protein molecules separated. But for some reason, water is removed, surrounding water is removed. Then those proteins bind together. We call it aggregation. Aggregation can be reversible or irreversible. For example, aggregate of proteins in this salt, ammonia sulfate can be converted if you remove the salt. But if aggregate by temperature, it's irreversible. Denaturation, similar to aggregation. If you try to break the structure of protein by heat, by temperature, or by chemicals, in that case, some bonds between amino acids will be broken, and protein lose its conformation. We call it denaturation. For example, in this case, this protein can be a functional protein, must have this structure. However, if you apply some heat or some chemicals structure, primary structure. In this case, we said this protein is the nature. And of course, the nature protein cannot function, has no function. And denaturation also can be reversible or irreversible. For example, if you boil an egg, albumin in the white yolk is protein. So when you boil egg, albumin is the nature because you apply heat. Is it irreversible? Although later you cool down the egg, albumin cannot convert it into the liquid form anymore. So this is irreversible.
So it means better to freeze egg raw.
Pardon?
Is it better to freeze egg raw?
I don't know, someone said it's better, but I'm not sure because if you drink egg raw, there can be some bacteria, yes. And patients would have problem in digestive tract. In that case, it may cause some problem in your digestive tract.
What about like to leave eggs into the fridge for the night, and then people said it's not good.
Yeah, if you boil an egg already and leave it in the fridge overnight, because when you boil egg, on the egg, actually there are some holes to have how say air transport in and out of the egg. So egg always have
Air circulation.
yes. So air can enter and go out of the egg to provide oxygen for the fetus inside if the egg is fertilized. So if you boil, those holes become enlarged, and if you leave it for a long time, overnight or so, bacteria can enter into the egg through those holes. So it can become toxic.
The fold and then unfold. That's when we add salt and when they unfold and
For application, it can be unfold or it's not completely unfold like denaturation. Partially unfold because it loses the water, so it will tend to tend to stick together post application, but not completely unfold and become polypeptide as denaturation. So the mechanism of the two processes are different. In this case, bonds between amino acids are broken and protein come back to polypeptide form. But in this case, maybe some bonds, covalent bonds, ionic bonds, are still available, but protein becomes stick together again in a water solution. Okay, so the role of protein, it can be catalyst, such as enzyme. Enzyme is the catalyst of metabolite reaction in our body. It can be structure protein, for example, the protein on the cell membrane, protein on our organs, on our tissue, and it can act as a transporter. So on the cell membrane, there are several proteins on the cell membrane. They are transporter to transport water, ion, glucose in and out of the cell. And in our body, hemoglobin is a transporter for oxygen. And protein can participate in the mobility of the cell. For example, actin myosin help muscle cell contract, and tubulin in the cell also participate in cell division. It help chromosome move toward the two poles of the cell during mitosis, or some protein participate in the flagellum or flagella of sperm or bacteria to help the cell move. So that is role. We also have defensive protein, such as antibody in our immune system. Storage protein. Protein can be stored as a source of amino acids in embryo. For example, casein in milk is a protein which is stored in milk to provide to the infant. Or albumin in egg are the storage protein for the embryo. And protein can be a hormone. We have some hormone protein such as insulin to control the biological activity of our body. Insulin is a type of peptide protein hormone. I think this is some summarize of protein. So, protein plays many roles in our body. And the monomer of protein are amino acids. We have 20 amino acids in the nature. Amino acids consist of carbon, oxygen, hydrogen, nitrogen, and sometimes sulfur. Is a hydrophobic, mean water fearing. And hydrophilic, mean water loving. We also have acidic and basic amino acids. This is how polypeptide bond form. So this is the primary structure of protein. Alpha helix. Alpha helix is formed by hydrogen bond. And beta sheet. Regulatory structure. So the side chain of amino acid interaction to form the regulatory structure. Some proteins require ion, metal ion for function. So this is a hemoglobin. This is globin with the hem rings inside.